So, a very good evening, everyone. The week 10 of the Crystal Symmetry and Tensor course has been over right now, and we are going to solve few questions and we will discuss all the doubt which you are having in this particular session, if there is any. Okay, and yeah, it's like our the course has been on the end of the particular this month, like in the April, there will be few more doubt solving sessions, two or three, and after that, there will be the exam on 27th of April. So for that, let's prepare as well for that and pile up your doubt if you are having, and then we can discuss those things. Let's get started and let me share my screen. Okay. Yeah. So, so in the week 10 of the particular course, the following content has been discussed in this particular week. The topic covered are as listed. So in this particular week, the initiation of the space group, we started discussing about this, and this has been done mostly. After that, there is a the confusion about the trigonal and rhombohedral and hexagonal confusion, which was there in wide range of the internet also available, and that is that confusion as our professor Rajesh Prasad has tried to clear it out. And then we discussed about the Bravais lattice in the trigonal crystal system. That what types of the Bravais lattice, that is hexagonal primitive and hexagonal rhombohedral. This both the lattice Bravais lattice has been discussed thoroughly. Then we discuss about the screw axis, how many screw axes are there, and how many screw operations that can be made using that particular axis. So we came out that there are total seven different types of screw axes are available to us, and that has been discussed. After that, the glide in 3D, there is a total of the six glide, that is A, B, C, D, E, and N. All of them are being discussed in the particular course in this particular week. After that, we discuss about the Symmorphic and Nonsymmorphic space group. That out of 230, out of 230 space groups, which of them are the Symmorphic space group? In detail, those has been 76 Symmorphic space group has been discussed. Okay, so with that, let's start with the solving the few questions based on this particular content. So the question number one, which we are having, it's very easy. That it's talking about the plane group. Okay, we know what is a plane group. We have discussed that in the extremely detail in last week, and it is asking about the what is its dimensionality and the translational periodicity. So we know in the phase group it is having the dimensionality of 2 and periodicity of 1, while the plane group has the dimensionality of 2 and the translation periodicity is also of 2. So here we can see that okay, yeah, it has the two dimensionality and the uh, 2D translation periodicity, and with that we can go with the option number B. Okay, so with that, the question number one is over. Now, this we already know that is a phase group, and this is a plane group. Now, let's go to the question number two. Meanwhile, let me tell you that if you have any question regarding if you have any doubt regarding this particular questions and or the lecture, the content which has been discussed in the lecture, You can always discuss with me, and you can unmute yourself and let me know your doubts. Let's go with the question number two. The question number two, we have to answer that the affine transformation representing six-fold rotation followed by the lattice translation B. So we are having the lattice translation B vector in the hexagonal crystal system. Okay. So we have to write the affine transformation. Affine transformation, we know that how we can write that there is a matrix part and there is a column part. Matrix part usually contain the information regarding the point symmetry. That is a rotation or mirror or reflection. Sorry, reflection itself is counted over here. And there is an inversion or the combination of them. For example, roto inversion. Okay. And the column part store the information regarding the translational periodicity. And here we know that the translation is by the vector B, right? So it's telling about the direction as well as the magnitude. So the translation part, we can say that, pardon, let me fix it. Translation part, we know that, okay, it will be 0, 1, 0. Second place, it will be 1 because we are having the B vector. Now we need to worry about the matrix part only. So we got to note, okay, yeah, so out of these three options, we can eliminate two of them. Okay, and this both will be eliminated. So our answer is A only, but yeah, still let's try to find the matrix part itself. So now in the matrix we know if it is following the six-fold rotation, it is a pure rotation itself. Okay, right. So we know how we can write the matrix part of it. It is a cos theta, sin theta, minus of sin theta, O, 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 and 1. And with that we can see that, okay, yeah, since theta is a rotation and rotation is by the 60, so we can see that cos 60 will be 1 by 2 and again 1 by 2, root 3 minus root 3 by 2 and root 3 by 2. With that we can see that, okay, option A is a correct option and we have solved it in the detail. So a fine transformation is always, we will always stick with this that, okay, I will start with the thinking that, okay, there is a matrix part is there and column part is there. How we can find the matrix part and how we can find the column part, and that is hidden within the question itself. So you have to do the match the pair. So this column contains the Bravais lattice, list of the Bravais lattice. Here it is a lattice system and there is a point group associated with them. Okay, so let's try to match them. Let's try to match. Okay, first one is a hexagonal primitive, right? So we know a hexagonal primitive, it can come in the hexagonal itself. Yeah, it can also come in the trigonal, but there is no trigonal. Okay, so we can left it. Now there is a next one is a orthorhombic with a body center. So we can see that, okay, yeah, we can match it with the orthorhombic. A means the triclinic, right? It doesn't having any of the, it's not having any of the axis, any of the length to be the equal with each other, neither the length nor the angles. So we can associate them with each other. Now, there is a M S. M is a stand for the monoclinic, S is stand for the end center. So monoclinic we can match with the this monoclinic is over. And C we know that it is cubic, so we are going to match with the cubic. So this part is over. Now let's match monoclinic with the point group associated with them. Okay, let's start with the first point group, 1 bar. We know 1 bar can come in the triclinic, right? So we're going to match with that. Then 6 over mm, that is a 6 fold is there. And we know that this will correspond to the hexagonal crystal system, right? So we are going to match with them. It can correspond to the hexagonal lattice. Remember, here we are matching with the lattice system. So we know that hexagonal lattice, if we talk about, hexagonal lattice can come in the two of the crystal system. So it can come in the hexagonal crystal system. It can also come in the trigonal crystal system, right? So we need to find we need to find the point group associated with this hexagonal, that is hexagonal also and cubic crystal system also. So we just found out that okay, 6 over mm is something which is associated with the hexagonal crystal system. What about is there any point group which is which is corresponding to the trigonal crystal system? And yeah, there is 3 bar m is a trigonal crystal system, so it will also correspond to the same crystal system. So now we are matching with this. Now let's move ahead. Let's go with the monoclinic. We know in monoclinic we can have the 2 over m. Yeah, it is there. Cubic we know highest symmetry 3 bar and 3 bar m. So we can match with them. What about the orthorhombic? Orthorhombic we can see that okay, yeah, m will be there. So with that we have finished this, and see mostly the confusion will come only here, which we will always remember that like our professor also try to clear out this confusion for us, that hexagonal lattice can contain both the crystal system. It can also correspond to the hexagonal crystal system. It can also correspond to the trigonal crystal system. And with that, we have understand this entire match the pair. So the question is telling that we have to comment on the below graphical symbol. So the graphical symbol, the way it has been written, the way it has been shown, that we can see that okay, there is a hexagon is there. So we can tell that okay, a six-fold is must there. Six-fold is there. So it is corresponding to the hexagonal. It can correspond. It is corresponding to the hexagonal. Now the another thing is that this line, it is representing that this is not normal six-fold. It is a six-fold with screw is there. And so okay, we got to know that okay, a screw is present, so we can say that okay, so with the rotation there is a translation is also present. And now we need to find that which of the screw it is. One thing we got to know that since it is a screw, so we got to know that 6 will be there, and there will be some subscript, and this subscript is something which we need to find. In the sixth fold, in the screw consisting of the sixth fold, we know that it can have 6 1, 6 2, 6 3, 6 4, and 6 5. That is, if n and m are representing at the screw, then m should be less than n. And with that, we have found the 5 pair. So out of this, only 6 3 is represented like this, because it is 6 3 means the overall rotation is by 120 degree, sorry 180 degree, right? And 180 degree is represented like this. So with that, we got to know that this is nothing but 6 3. So let us comment few more thing on this particular rotation axis of 6 3, screw axis of 6 3. So we got to know that we will rotate by 60 degree. But the translation is by how much amount? Along the direction of the screw, along the direction of the axis, along the direction of the axis, the amount of rotation, the amount of translation will be by how much? Okay, so we are having these two things. One is this number itself, and there is a subscript associated with them. What we need to do, take a subscript in the numerator and divide it by the this particular fold of rotation with the by in the denominator. Whatever it will come, whatever the number it will come, with that amount we have to translate, multiply with by lattice along the axis, lattice translation. So along the axis, for this particular thing, we will divide by 3 over 6, that is 1 by 2. So along the axis, along the lattice translation along the axis, we will translate by half of the lattice translation and rotate by 60. Then again we'll rotate by 60 and translate by the half of the lattice translation. And with that, we can comment on this particular graphical symbols. Okay, so let's draw one more graphical symbol. So now, what this will graphical symbol is telling us about, we got to know that since this is on the right side, we can say that okay, as this is, first of all, this is sixfold, this is confirmed, but the screw is of the sixth one, right? So here the translation is by the amount of 1 over 6 along the lattice translation along the axis. So with that, we can comment on this particular graphical symbol. If there is any doubt regarding this, first please go with the video which we have, video of the Professor Rajesh Prasad, and it will be much more clear. And then if there is any doubt left, please let the question is very simple, extremely simple. So here is the screw axis is there to shown to us, and then there is a fold of rotation we need to find, and then the lattice translation parallel to the rotation axis. This is something which we have discussed just right now, that how we can find the lattice translation parallel to the rotation axis or along the rotation axis in a given screw axis system. Okay, so these are the screw axes given to us. So the first one is telling about the two-fold rotation, and there is a screw. Subscript is associated, so this is a screw. So we can write the fold of rotation very easily that it is T. Now the lattice translation parallel to the rotation axis. How to find that? We know that whatever is in the subscript, we'll write in the numerator. and then we will divide it by the fold of rotation diameter. So by this much amount, let us say C is along the rotation axis. Let it translate along the rotation axis. So we can say that C by 2 is our translation vector. Now for the C2, sorry 3 2, 3 is a rotation axis. Fold of rotation is 3, and by what amount we are going to translate, again we'll follow the same rule. Subscript in the numerator and divide by the whatever the fold of rotation is having, that is 2 by 3. So on and so forth. One can fill this out. This is 4 and this is 1 over 4, 1 by 4 of lattice translation. This is a 4 over 2. So the fold of rotation is 4 and it is by the 2 by 4. So which we can write as 1 by 2. There is a slight confusion. People might sometimes get that they think that 2 1 and 4 2 they are same. They are same by the lattice translation, but they are not same by the rotation. Okay, so for a time being, if we say that we are rotating something by 180 degree, starting from this, we are rotating by 180 degree, and then along the axis we are going to translate it. This is for the two-fold. If the same point, if I rotate by the four-fold, we are going to over here 90 degree has been completed, and the amount of translation is by the same amount. So they both are at the same height. Their height are same, but their rotation, and since their rotation are different, so their places are different, and that's why these two are different from each other. They are not equivalent with each other. Okay, so let me write 2 1 and 4 2. They are not equivalent with each other. Okay, so now let's complete about the rest of the part, that is 6 3, which we have just seen right now. That is okay, fold of rotation is 6 and 3 is telling about the lattice translation, so 3 by 6 it will be written, and 1 by 2, again the 1 by 2 is there, and 6 4 we can say that yes, fold of rotation is 6 and the translation is by the 4 over 6, which will be the 2 over 3. Again 3 2 and 6 4, they are not equivalent with each other. And with that, we have completed the question number 5. If there is any doubt, please let me know. Or so now let's talk about this question. So the graphical symbol has been given to us, and we need to complete the table. Okay. So in this particular table, graphical symbol is there. Orientation of the glide plane with respect to the projection plane. This is something which we need to find, and the direction of the glide. Okay. So what we know that glide glide involve two things. That is, first it will take the mirror, and also it will translate. Now we need to find in this particular question that how the mirror is oriented with respect to the projection plane, and with respect to projection plane and this particular mirror, what is the translation, in which direction translation is happening. Let us say this direction is B and this is A, this is B and this is A. Arrow is pointing toward B in this particular case, and arrow is pointing B. Okay, so since this is represented, this typographical symbol has been represented, so we got to know that okay, yeah, so the glide plane is oriented along the parallel to the projection plane. So if this is my projection plane, so if it is written like this, then we know that okay, our glide plane, our mirror is somewhere over here. It is parallel to the projection plane, or it is along the projection plane. So the glide plane with respect to the projection plane, they are parallel with each other. Same do in the case of this, they will be parallel with each other. What about the direction of the glide? Since the arrow is pointing toward the B, we got to know that the direction of the glide is along the B vector. Here, the arrow is pointing toward the A, so we got to know that the direction of the glide is along the A vector. So that's how we solve this particular thing. Now let's move to this third and fourth part. This type of symbols, this type of dotted lines will be there only when we are having the glide plane mirror which is perpendicular to the projection plane. So yeah, so if it is perpendicular projection, we are going to have something like this. So here we can say that they are the perpendicular with each other. So the if this is our projection plane, so our glide plane will come like this, perpendicular to it. Same will go for this also. It will also be perpendicular with each other. But the thing is that since both of them are perpendicular with each other, now we need to find the direction of the glide. Okay. So now here both of them are perpendicular with each other. So now the direction can be along the, let us say this is our glide plane. Okay. So the our direction can be along this direction of the direction of glide can be along this translation. Okay. Translation can be along this or it can be along this. If the translation is along the this along the projection plane, sorry, along the glide plane, then we can say that this particular type of dotted lines are represented. So here we can say that this particular symbol will be used for this. So we can say that along the glide plane. And this type of dotted ones, extremely dotted one, they will be used for the perpendicular to the glide plane. Okay. So if there is any confusion, let's clear it. Let's say we are having this, and I'm trying to clear about these two things. Okay. In three dimensions, it is quite easy to understand. Let us say this is our projection plane, and this is our glide. This is our glide plane. So the glide plane and projection plane are perpendicular to with each other. So we got to know that okay, we are in this particular symbols. Now let's move ahead. So now the translation can be along the glide itself and can be perpendicular to the glide. Okay. So the translation can take two. It can be along this and it can be along this. So when it is along this, then the way let me draw this particular projection plane. we will use the dotted type of this type of symbol. But when it is along the glide plane, then for the same thing, we are going to use things like this. Okay, let's move to the next question, question number 7. So here we need to find the overall the question is telling that how one can transform from A to B. A is over here and B is over here. Okay, this is Z and this is Z plus 1 by 2. Let's see what are the things has happened to the A, what things can happen to the A which can transform to the B. Since there is a change in the headness, we can say that okay, there will be the mirror will be associated. We can take a mirror along this. If I take the mirror along this, so we can translate from this to this. So we can reflect them over here and the headness will be changed. But even if I, let us say I somehow able to make it over here, still a lot of operations are left. One of the operation is that the translation by the amount of b by 2 in this particular direction. That is, if I say this as a reference, I'm just taking as a reference line. So the b by 2 translation he will bring over here. So the half translation in the b direction. But that's still not the case. We have not reached the point B yet. Because point B, Z is 1 by 2, Z plus 1 by 2. In the C direction, Z plus 1 by 2. Here, in the C direction, only Z. So along the C direction also, we have to move by the amount of 1 by 2. In the C direction. So these are the things that need to be carried out. Right. So now let's think what are the things which are it's not clearly, since two translations are involved over here, so it's clearly not a simple axial glide. Okay, so out of A, B, C, D, E and N, we can eliminate A, B and C. Diamond glide, if I talk about D, it will involve the translation by the amount of 1 by 4. But here we can say the translation is happening only by the amount of 1 by 2. So we can eliminate this also. E, which is double glide. A double glide means it will glide in two directions, but it will produce individuals. They are not. It's not like the sum of the translations. A plus B is not happening. Here it's A and B. Translation along the A and the translation along B. It will produce two independent points. Since we are getting only one point over here, so we can eliminate this also. So now only thing that is left over here is the this diagonal glide. So we can say that okay, it is a diagonal glide. Which is represented by the n. So the A is over, B is over. Now C and D, that they are telling that okay, this is a diagonal glide. But again, the question has remained. One of the question we need to answer that whether the glide plane is parallel to the projection plane or it is perpendicular to the projection plane. Once we know that, we can clear it out among C and D which one it is. So we have to reflect about this particular axis, about this particular mirror, so that we can get it. So this particular plane, if we cut it along this, we can see that okay, this projection plane is perpendicular. This glide plane is perpendicular to the projection plane, so we can say that it will be perpendicular. So option D will be the correct option. So just by knowing that what is happened to the particular point A, which can translate to the point B, set of the operation which can do that. Out of the list of this particular six glide, we can find out that which one it will be corresponding to. And so with that, we have solved the question number 7. Now let's move to the next question. If there is any doubt, please ask me. Again, the things has remained same. That is from A. This question again is asking us how you can transform A to the B. Okay, which glide or which translation, what it is. So let's figure out what has happened to the A and B. What can happen to A which can transform it to the B. So A, we can see that okay, A and B, there is a from A we can say that okay, handedness we need to change of handedness. So it can be done by the mirror, right? Also Z, which was along the plus along the Z direction, it has become to the minus of Z. This can also be done by the mirror. We can do it by the mirror, but the mirror should be perpendicular to the Z. Then only it can mirror it, right? So let us say this is our Z direction, or let us say this is our C direction, and this is a plane, mirror plane. Then only it can reflect this particular point, this C to over here, minus of C, right? So this can be done by the mirror, but mirror should be perpendicular to the Z axis. Now let's see what else has happened. It has translated by the amount of B by 2. Right. So along with this particular things, there is a translation also. Along with this, there is a translation B by 2 of translation. So the translation is there, mirror is there, so we can say that okay, the glide is there, glide is present to us. But we need to find which glide it is. The translation, there is only one translation is involved over here. Remaining thing can be done by the single mirror. So it can be the axial glide. So in this particular axial glide, what we can say that this particular axial glide, the translation is along the B, so it is the B glide. Okay, so we can say that this is a B glide is there, but the mirror where the mirror is present with respect to this particular projection plane, with respect to this particular projection plane, mirror is also along this itself. Then only the Z will come to the minus of Z, and the handedness will change also, right? And the translation is along the B, so we can represent it like this. And so with that, we have found that okay, it can be done by the B glide. So B glide is the upper answer. So question number 8. That's how we have solved it. Okay. Now let's go to the next question. Question number 9. So in the question number 9, it is telling that we have to select the symmorphic space group. That is a space group which doesn't involve the non-lattice translation. Symmorphic space group is a translation operation, we can say, which doesn't involve the non-lattice translation. So these things are not there. If these things are not there, it means that there won't be any screw. Screw is the one which lead to the non-lattice translation, and the glide also. These are the things shouldn't be present. From the name itself, let's try to find P M M N. So P is there, M M N. P is fine. Simple translation will do. Mirror is there, okay. It's not a glide, it's a mirror itself. So mirror is there, okay, yeah. N. So we know that N is a glide, right? So we cannot select this particular. This will non-symmorphic space group. So with that we can eliminate A. What about the second one, P222? P is a simple translation, lattice translation, a rotation, and rotation. Twofold rotation. They will also produce only the lattice translation itself. So B is a we can consider it. C1. Let's talk about the C. F D D D. Since D is there, we can say that okay, this is a glide. So glide is not considered. P4 over M. So P4 over M. So this is a pure rotation and this is a mirror. Nowhere there is a glide, nowhere there is a screw, so this is also present. What about the P4 N and C? Since N is there, N is a glide. Again N is a glide. C is again a glide, so eliminated. So our only answer is this, A and D. Sorry, B and D. P222 and P4 over M. And with that we have solved the question number 9. So if there is any screw also, let us say P2 1 over M, we will let us say this is F. We will remove this also because 2 over 1 is a screw and screw is something which is not considered. Okay. So now let's move to the next question, question number 10. We need to complete the operation on the given symmetry elements. Okay. So on the general position, this particular point is a general position. Okay. So we are going to, on this particular projection, we are going to apply this operations. Okay. Let us say along this particular points, these are the lattice points on which we are applying this. So M 2 point group we are applying on all this particular lattice point. It is a P MM2. What we are going to get? That is something which is we want to know. There is a twofold, right? It is telling that this is a twofold. This is a mirror, and this is a mirror. Let's apply over here. This is a twofold. This is a mirror, and this is a mirror, right? So let's move ahead and do it. So let's go with the twofold first. What twofold is going to do? It will going to rotate this particular point over here by 120 degree. It will come over here. It is plus. It will also remain plus because along the C axis it's not going to change anything. Since it is above, it will also remain the above the projection plane. A rotation will again keep it as it at its place. It's not going to change the c direction, the length along the c directions. Now next part is that we need to take the mirror of it. This is a mirror. Let's take its mirror. We'll get over here. Again, mirror is again not going to change the c direction. It will remain positive. But what will mirror will do with respect to this? It will change the handedness of it. This point has reflected over here. Now this point will again reflected over here. Plus again the handedness will change. So with respect to all the points, all the remaining lattice points, we can perform this particular operation, and this is what we are going to do. Okay. So about this point, if it is not clear, let me do it over here. So this is a twofold. This is our point, initial point. We have rotated by the 120 by 180 degree. We got over here. Let's take a mirror. We will get over here. Again, it will remain positive, and but the handedness will change. Again, it will remain positive itself, but handedness will change after the reflection. This mirror is a by default mirror, but generated by all these things. Right? We can say that twofold with this particular thing is generated over here. And with that, we have solved this particular question. Right. Now, all the things will, like, if you associate this particular operation point group onto all of this particular lattice point, you will generate additional rotation axis over here, additional mirror planes. That is going to remain same. So one can do all these things, but our my way to answer this particular question, my aim for this particular question was just to know that okay, yeah, how these things are going to change if I associate this with this particular point, this particular space group with this particular point group with this. Now again we have to do the same things on this particular. Yeah, we have to do the same thing on this particular point group, on this particular elements. So this is the element which is given to us. It is and we are associated with the general position itself. What is this? First of all, what this particular operation is telling us about? So it is telling that okay, yeah, so there is a threefold is there. This triangle is representing the threefold, and we know that this type of extension is only done in the case of the screw. So the for the screw we know the fold of rotation, but we need to find the translation. Translation by how much amount? For that we need to know that whether what is the subscript of this particular screw. This particular screw, what is the subscript? So for the threefold, we know that there is a axis 3 1 and 3 2. 3 1 is represented like this, while the 3 2 is represented like this. And we know that this is the given figure to us. So we got to know that this is a 3 1. So the translation it will involve will by the we can find it by this considering this as a numerator and 3 to be the denominator. So 1 over 3 is our translation in this particular screw axis. So now let's apply this to the this particular point. Threefold. it will be better if I draw. Okay, let's say we are starting over here, and I am rotating by the amount of 120 degree threefold. We got somewhere over here. So along this, let us say this is our c-axis. Now we need to translate it by the amount of 1 by 3 of this particular entire, that is translation. So this is 1 by 3 over here. Now again from here, we'll rotate by the 120 degree. We'll get to this particular point. Again we'll translate by the 1 by 3. Then again rotate by the 120 degree. Over here we'll get, and then again we will translate by the 1 by 3. So overall we are going to produce, again we got the at the final position itself, right? So how many points including this 1, 2 and 3 point we have produced overall. This we are including, this is the first point. Now rotate it by 120 degree, rotate by 120 degree. Let us say that will come somewhere over here. It is plus, it will remain plus itself, but in the z direction it will be the whatever it is, let us say it is z, so it will be the z plus the translation is by the 1 by 3. Now again this will rotate, we'll get over here by 120 degree, that is this particular point. Again it will remain plus z 1 by 3, again 1 by 3 will be added to it, it will be the 2 by 3. Now again if you rotate, we'll get to this particular same point which is represented over here, and that's how we can complete this entire diagram. So if you associate this particular screw with all the lattice point, we are going to get this particular type of structures. Like given general point will produce 3 more additional points with itself. Okay, and that's how we have solved this question number 11. And that was all the question that I had from my side. If there is any doubt, please let me know. Okay, since there is no doubt, let's wrap up the today's session. And if you later on, if you are able to find any doubt or any difficulty while solving the question, you can please let me know in the doubt forum, and we'll definitely respond to it. Okay. All the best for the this week assignment, and let's meet up again in the next particular upcoming week.